Good morning, folks. I'm going to give another short video about RW this time. Now, what's the most problematic parameter that we have when we're in a rank exploration or appraisal situation? It's usually RW, isn't it? We normally have a good idea of porosity and a fair idea of lithology, etc. RW, for the calculation of saturation, is normally the most difficult thing to get a handle on. So I've got a little trick here that helps us to get some idea of what the RW is, and it's pretty simple. Firstly, I want to say that we should really try to communicate in terms of, well, we should communicate in terms of salinity, not RW, because, for example, if I say to you the RW of that rock is 0.34, it doesn't mean much to me, actually, and doesn't mean much to people you're talking to. But if you say the salinity in that formation is probably about 35,000 ppm, then you immediately have a grasp of what's going on. You think, oh, it's like seawater, for example. Okay, so try and communicate in terms of salinity. It's a lot easier to understand and to communicate with, and also it just requires you to do a little calculation in your batch file between the RW values and the equivalent salinity values, which I've got an equation for, and I'll show you shortly. Okay, so let's flip over now to the slide and see what I mean by calculating this apparent salinity. Okay, here is the slide, and we've got the RW apparent calculation, NaClA, a useful curve during exploration. So we assume all of this rock is full of water, and then we say to ourselves, well, if it's all full of water, what does the observed resistivity have to be? If we assume it's full of water and we have this observed resistivity, what does the salinity have to be in order for that to be full of water? And we calculate that curve there, which is called NaCl apparent. How do we do that? Well, here are the two equations. This is RW apparent from the Waxman-Smits equation. That's RW apparent, Waxman-Smits. And we've put in the logged value of resistivity, which we're assuming is R0. That's the water saturated value of resistivity. And then we're taking that and we're putting it into the conversion to NaCl, or salinity, right? And that's the equation to do that. So that goes into there, and we get the apparent curve for salinity, and we plot it in this nice little graph. I normally use 1000 to 100,000 for the n members as a logarithmic scale, and we can see that when we plot that, we get some values that are really quite fresh, aren't they? This nice zone here, which actually was the best zone, went down to about 3000 ppm. So I said to the geologist, well, do you think it's reasonable that this rock would have 3000 ppm water in it? And he said, no. So we talked about it a little bit more than that, but anyway, we talked about it on and off, and basically, you know, it gave us the feeling that those rocks up there, those intervals up there, were obviously not full of water. They had to have some hydrocarbons in it. I mean, we don't know exactly what the salinity is. We can assume, if you want to, that this zone, of course, is at R0, and it is fairly constant. So that might suggest that that's actually the real salinity. And if you do that, you can then calculate the saturation. Okay, so that's the idea. You can do some more clever things with this concept. You can assume that the rock, you can see what the observed salinity, you can see what the observed resistivity indicates the salinity of the rock is if it's at irreducible water saturation. Now, there is most rocks, most classics are about 0.06 or 0.07 bulk volume water when they're at irreducible. Okay, so if you use 0.06 as the bulk volume water at irreducible, you can then work out the saturation and then work out the salinity for the observed values of porosity and resistivity. And you can get another curve in there, which is the NaClA at SWI. But we don't need to go into that complication for this particular exercise. We can just see that that's a quick and easy way to get some idea on the salinity of these rocks. Okay, folks, that's all I have to say about that. So, bye-bye.